Ninth grade physics, part 3, starting at number 51. Number 51, which of the following correctly expresses Newton's second law relationship? Is it A, force is equal to mass over acceleration? B, acceleration is equal to force times mass? Or C, mass is equal to force over acceleration? 52. What is the weight of gravitational force on a 200 kilogram rock? Is the weight of the gravitational force A, 20 newtons, B, 200 newtons, or C, 2,000 newtons? 53. When an object is accelerating due to force of gravity with no other forces acting on it, it is A, in free fall, B, in terminal velocity, or C, motionless. 54. If you were to drop a small metal ball in a car at the same time and from the same height, which object would hit the ground first? A, the metal ball, B, the car, or D, hit at the same time? "55. If you drop a golf ball from the top of a 6-story building, it will hit the ground after about 2 seconds. What is its speed when it hits the ground? Is it A, 40 meters, B, 20 meters per second, or C, 12 meters per second? 56. A washing machine in a free fall has an average speed of 15 meters per second. If it fell for 3 seconds, how far did it fall? A, 5 meters, B, 10 meters, C, 45 meters, or D, 125 meters? 57. If a cat is thrown up in the air, it goes up for a while, reaches a maximum height, and then it comes back down. What is its velocity at the maximum height? Is its velocity A, negative 10 meters per second, B, 0 meters per second, or D, 10 meters per second? The same situation as the previous problem with the cat in the air. At its maximum height, what is its acceleration, they're asking now? A, negative 10 meters per second, B, 0 meters per second, or D, positive 10 meters per second. 59. A football is thrown downward with a velocity of negative 2 meters per second. When it hits the ground 2 seconds later, its velocity is at negative 22 meters per second. How far did it fall? Is its answer A, 57 meters, C, 10 meters, or D, 24 meters? 60. A 20 kilogram cucumber accelerates across a smooth icy lake at 2 meters per second with a net force of blank. What is its net force? B, 10 newtons, C, 40 newtons, or D, 80 newtons? 61. What mass of wood did a woodchuck, if it used 60 newtons force and the wood accelerated at 3 meters per second squared? So we're looking for the mass, and we have the 60 newtons and we have the 3 meters per second squared. What is its mass? A, 20 kilograms, C, 180 kilograms, or D, 540 kilograms? 62. A 100 Newton force is applied to a 5 kilogram bag of sugar, like in a grocery store. What is the acceleration of the sugar? A, 5 over 100 meters per second squared. C, 20 meters per second squared. Or D, 500 meters per second squared. All right. 63. An object has an acceleration of 8 meters per second squared. If the net force acting upon the object is tripled, what is the new acceleration would be at meters per second squared? Is it B, 8 over 3, C, 12, or D, 24? Moving on to the next set of problems. We're almost finished here. 64, or let me read the question first. The north end of a large 2,000 gram magnet is brought into contact with the north end of a small 20 gram magnet, and then they are released. The magnets repel each other, moving farther away from each other. So it's like when you put two magnets close to each other and then they move away because of the opposite forces. So 64 asks, which of the following statements is true about the forces involved? A, the force of the 2,000 gram magnet is larger than the force of the 20 gram magnet. So true, forces are larger. B, the force of the 2,000 gram magnet is smaller than the force of the 20 gram magnet. Or C, the force of the 2,000 gram magnet is the same as the force of the 20 gram magnet. 65. Which of the following statements is true about the acceleration of the two magnets? What about the acceleration? A, the acceleration of the 2,000 gram magnet is larger than the acceleration of the 20 gram magnet. B, the acceleration of the 2,000 gram magnet is smaller than the acceleration of the 20 gram magnet. Or C, the acceleration of the 2,000 gram magnet is the same as the acceleration of the 20 gram magnet. 66. If you push against a wall really hard, you might exert 100 newtons of force on it. With what force does the wall push back on you, and why do you say so? A, 0 newtons, because the wall is on moving object, so it can't exert force. B, 10 newtons, because the wall doesn't move, so it can't exert as much force as you. Or C, 100 newtons, because the wall will always exert the same force you do. 67. You hit a nail with a hammer. The nail goes into the wood about an inch, and you notice the hammer bounces back towards you slightly. What can you say about the force or forces that acted here? A, the nail exerted a force on the hammer at the exact same time as the hammer hit the nail. B, the hammer exerts a large action force on the nail, and a fraction of a second afterwards, the nail exerts a reaction force that caused the hammer to bounce back. Or C, the hammer only bounced a little because the nail was too small and was moving too slowly to exert a big force on the big, heavy, faster moving hammer. Alright, just a couple more questions. 68. If you give your textbook a push on the table and let it go, it starts to move slowly due to its backward frictional force exerted on the book by the table. We call this friction an action force. What is the reaction force that forms a third law pair with it? So what's this reaction? A, the table exerts upward force on the book. B, the book exerts a forward force on the table. Or C, the earth exerts a gravitational force on the book. 69. An air hockey puck slides across a frictionless game table at a constant speed of 400 millimeters per second. You want to learn about any forces acting on it. Which Newton's law would be best to use here? A, the first law, B, the second law, or C, the third law? And finally, question 70. Even though every action force has an equal but opposite reaction force, they do not cancel another out. And the motion may still occur because the A, action and reaction forces are applied to the same object. B, two forces have different magnitudes. Or D, action and reaction forces are applied to different objects. You are finished with your essential physics exam. Please take it up to the teacher in the computer lab or in the classroom. Thank you.